Okay, number 31 on section 3.7. Now, this is just the extension of the power rule. Up to this point, the power rule was just just applied to positive and negative integers, and now we've expanded it because by using implicit differentiation, it allowed us to be able to prove the power rule exists also for rational powers of x. So now we're just expanding that to rational powers, to fractions. So that's all we're doing. So now we have the same thing. We multiply. So it's the same thing. In other words, if y equals x to the n, y prime equals n times x to the n minus 1. And now, again, n can be rational numbers, fractions. Okay, that's all we're doing on these problems. Okay, x to the n minus 1, n times x to the n minus 1. All right. So all we're doing is if we take if y equals x to the 9/4, then dy dx equals, this is the n, so it comes down in front, 9/4 times x to the 9/4 minus 1. What's 9/4 minus 1? 9/4 minus 4/4 is 5/4, so just 9/4 x to the 5/4, so that's pretty easy. Number 33, now we can do radicals other than just the square root. We have that special rule for the square root, but now we can expand this to any kind of roots because we just changed the root to a rational exponent. So remember, we know that the y equals the cube root of x is the same thing as x to the 1/3, and then we can apply the power rule. So dy dx would be just 1/3 times x, and then what's 1/3 minus 1? Well, 1/3 minus 3/3 is negative 2/3. So this is, I think, the way they had the answer listed in the book, but you could, lots of times you'll want to have a positive exponent, so we could also see the answer like this. So that's an alternate way of writing the answer. Okay, and then number 35, we have kind of a chain rule application here. If we look at 35, 2x plus 5, so this is a function, so now we have some function. All right. Okay. Or f of x to the negative 1/2. So we have to use the chain rule. That's what we're saying. So something to the 1/2 would be negative, or something to the negative 1/2. We would multiply negative 1/2 times that something, subtract 1, so that's going to be negative 3/2, but then we have to take the derivative of the inside function. So the outside function would be like x to the negative 1/2, and the inside function would be 2x plus 5. So again, we take the derivative of the outside function, so that would be negative 1/2 times that something times the evaluated at the inside function, leaving the inside function alone. All right, and then subtracting, so to the negative 3/2, so we would subtract 1. And that gives us the same thing as the derivative of x to the negative 1/2 times the derivative of my function on my inside. So I wrote it out for you. You don't always have to write it out, but just so you remember. Our chain rule technique. And then again, this is the same thing, nothing to the left of the dx we change, just to the right. And we take the derivative of the inside function, and the derivative of 2x plus 5 is just 2. Okay? And then 2 over 1/2 just becomes 1, so we end up with just negative 2x plus 5 to the negative 3/2. And I believe this is the way the answer was in the back of the book, but sometimes we want to have a positive exponent, so sometimes we'll bring it right down like this and make it negative 1 over 2x plus 5 to the positive 3/2. Okay? So it's just the power rule. If y equals x to the n, y prime equals n times x to the n minus 1. You just subtract 1 from the fraction. So I hope that helps.